So hi students, so welcome to the session. I am Dr. K.Varada Rajkumar, Associate Professor, Department of CSC AIML, MLR IT, Hyderabad. In today's class, we are going to learn how to implement queue using array. In our previous class, we learned about definition of queue and we learn different operations in queue. So overview of today's presentation, so we are going to implement different functions, implementing the queue using array type of data structures. Here we are going to implement queue ADT using array. In queue ADT program, we have different functions. One is initialize queue, is empty, is full, enqueue, dequeue and display functions. And after completion of this lecture, you all are going to implement queue using array in C programming. So this is the outcome of this lecture. So based on our previous class, you all are know there are three operations we are going to do in any data structure. So one is insertion, second one is deletion, and third one is display. Okay, so insertion means insert an element into queue. So that operation here we called as enqueue. So what is enqueue? Adds an element to the rear of the queue. So what is the rear of the queue? Here let us consider, so this is the queue, size is 5, the name is queue, array name is queue, these are the indexes. Okay, all the insertions are made using a variable known as rear. Okay, so initially the rear and front value we initialized with -1. So that is the initialize function. So what is the initialization in queue program? You can initialize two variables front and rear equals to -1. That is the initialization. Now here we are implementing the queue using a structure known as queue. In that structure we define items, that is the array name. So here this is the items. Okay, this is the items and front value and rear value. So these are initialized with -1, -1. I hope you all know this arrow. This you learn in C programming. To access the elements in the structure, we are going to use arrow symbol. Okay. And now enqueue. So now I call enqueue 50. Now this is the queue address. So this is the structure. So this is stored in memory. In that we have the items. Okay. So queue asterisk queue means it sends one address of this queue here. Okay. So int item is 50. So now is full. So already we discussed in our previous class. Is full means if I want to insert an element, there is a space in the queue, otherwise we can't insert. So first inserting the value, we are going to check the queue is full or not. So what is the full? How we can find that queue is full or not? If the rear value equals to size -1, max size -1. So then we consider that as a full. We consider that as a queue is full. Okay. In this case, what is the rear value? The rear value equals to -1. Okay, initial value. So rear equals to -1. Okay. Now this is false. So we enter into else block. So queue arrow rear ++. Okay. To insert, we are going to increment rear. So rear becomes 0 now. So this is the rear. Now you are going to store this 50 in items of 0. So 50 is inserted here. And you check that, so queue front equals to -1. So if the first element is inserted into queue, then I am going to make the front value also equals to 0. That's it. So this is the insertion. The same algorithm you are going to apply. Pause the video and try to insert a new element. So for example, NQ 60. Now again 60. Come to here. Is full? No, it is not full. Why? The Q arrow rare equals to max size minus 1. Max size here is 5. 5 minus 1, 4. Now what is the rare value? It is 0. 0 less than 4. Yes. It is false. So we come to else part. Now Q arrow rare plus plus. So now it becomes 1. In this place I am going to insert 60. Again same rare plus plus I am going to insert 70. Again if I want to insert 80, rare plus plus 80. Again I want to insert 90, rare plus plus 90. Now what is the rare value? The rare value is 4. Rare value equals to 4 now. Now I want to insert another number 100. Now what happened? When we enter into this block, we check is full. Now how we know that? Go to is full function, check what is the rare value here? 4 equals to max size 5. 5 minus 1, 4. 4 equals to 4, true. So it returns true. So this block become true. So it prints Q is full. Okay. So this is about NQ function. So next function is DQ. DQ means removes and returns the elements from the front of the Q. Okay, let us assume this is the Q. Size is 5, 0, 1, 2, 3, 4. Let us assume the Q name is items 50, 60, 70, 80, 90. Now you say what is the rare value? Rare value is 4. What is front value? Front value equals to 0. This is the front. That's it. Now I want to delete an element from the Q. So which element is going to be deleted first? 50. So this is the function is empty. What is the purpose of is empty? For example, so this is the array. I want to delete an element from this array, but array is empty. How we know that? If the front value equals to minus 1, then we assume that the Q is empty. Here you can write rare also. Okay, rare equals to minus 1, then also Q is empty. Okay, so now in this case the Q is not empty. How we know that? The front value equals to 0 now. So we move to here, else part. Item equals to, so items of front. So what is the item of front? 0. Items of 0. Front value equals to 0. So what is items of 0? 50 is assigned to item. To know the which element is deleted, and we check that front equals to rare. So once we delete all the elements, both the front and rear is at same position. So we are going to assume that the Q is empty and make this front and rear equals to minus 1. Okay, and here we are going to increment front plus plus. So now the front becomes 1. That's it. So this is the function for the deleting an element from the Q. So last operation, display. Let us assume this is the array. So array name is items. These are the indexes. So let us assume these are the elements stored in Q. Now pause the video and write what is rare value and what is front. So rare, what is the rare value now? 3. So what is the front value? 0. Okay, so this is the front, this is the rear. Now if we display the numbers, we are going to display 50, 60, 70, 80. So we start from front value. We write here. So I equals to Q arrow front. Initial I equals to 0 now. And I, that means 0 less than or equals to rear. What is the rear here? 3. True. So enter into the block, you are going to print items of I. What is the items of I here? 50. So 50 is displayed on monitor. Next I plus plus 1. 1 less than or equals to 3. True. So you are going to print 60. Next iteration 2. 2 less than or equals to 3. True. So it prints 70. Next iteration I becomes 3. 3 less than or equals to 3. True. So it prints 80. Next iteration I becomes 4. 4 less than or equals to rear value is 3. Now false. So this is the output 50, 60, 70, 80. Okay. Here also we are going to check E is empty. What is the purpose of E is empty? Here I want to display the elements in the queue, but the queue is empty. That means I want to display the elements in this queue. Here the queue is empty. How we know that? We are going to call E is empty function. In we write that front equals to minus 1. In this case the front value equals to minus 1. Okay. So it prints queue is empty. Okay. So now we see the execution of the program. So this is the actual program. So this is the structure and initialize queue, E is empty function, E is full function, NQ to enter an element into queue, DQ delete an element from queue and display all the elements in the queue. Now this is the main function. Here I create one queue here. The queue name is queue, that is a structure. Okay, and initialize the queue with the address of queue. So when what we write in the initialization, we write front equals to minus 1, rear equals to minus 1. Now this is the queue object is created for queue structure. Now I call NQ 10. That means I want to insert the 10 into queue. So this is the queue. So this is the array name. These are the indexes. Here I call NQ 10. You ignore the ampersand queue. This is the address of the structure queue. Okay. NQ 10. So I am going to insert the 10 here and I increment the rear value by 1. So 0. Next I insert 20, 30. Okay. So display queue. Now what is the expected output? The expected output is it prints all the elements in queue. So expected output is 10, 20, 30. Okay. So next DQ. So DQ means I want to delete an element from the queue. So what is the deleted element now? 10. So 10 is the output. So next again DQ. So 20 is deleted. So front value equals to 2 now. So rear value equals to 2 now. Now NQ 40. I want to insert another element. So 40. If I display, it displays 30 and 40. Okay. So let us check the code. So this is the output 10, 20, 30 DQ'd 10, 20. So queue contents are 30 and 40. Okay. So let us check. So queue is full or not. So here I insert 6th element. Here I am considering the size with 5. Now here I try to insert 6th element 300. Now we check. Here it display one message queue is full. I try to insert the 300 but it returns an error message. So queue is full, cannot NQ, and the queue contents are 10, 20, 30, 100, 200 only. Okay. So let us delete all the elements. Here, so 3 elements are inserted into queue, 3 elements are deleted. Now I am going to display the queue. Now it display, so queue is empty. Okay. So queue contains 10, 20, 30, 10 deleted, 20 deleted, 30 deleted. Now I want to display the elements, but no elements present in the queue. So it displays queue is empty. Okay. So let us summarize the points what we learn in today's lecture. So let us summarize the points. So what we learn in today's class. So we implement queue, array based queue implemented in C. So we define a structure queue that contains an array, items, rear and front value, so front index, and we implement the functions initialize enqueue to insert an element into queue, dequeue function to delete an element from the queue, and check emptiness is empty function to check whether the queue is empty or not, and we write one function to check fullness of the queue is full function. Okay. So this is about implementation of queue. In next class we are going to learn about what is priority queues. If you have any doubts, so place your doubts in the comment section. I will answer all your questions. Thank you.